Hi guys, so this video is going to show you guys a few examples from the homework in section 7.2 on how to apply these addition and subtraction formulas. So I'll try to bring an example that would apply each of these equations. So recall that this first equation, this guy is really the one equation that we derive by using geometry and doing a whole bunch of arguments. And all of these, the rest, well, we got the rest by just kind of playing around with that first equation, rewriting it from addition to subtraction, and then applying a whole bunch of previous trig identities like the co-function identity and the even and odd function identity. Cosine is even, sine is odd. Okay, all right. So how would I apply all these new formulas? Well, now, because I know how to take cosine of two angles, the sum of two angles, we can consider trying to figure out what is cosine of, for example, 75 degree. Now, 75 degree is not an angle from one of those special right triangle. It's not from the 30, 60, 90 degree right triangle, nor is it from the 45, 45 right triangle. But 75 degree, if you break it down, it is the sum of two very nice angles. It is the sum of 30 and 45. Okay, so I do know how to take the cosine of 30. I do know how to take the cosine of 45. And so we get to apply the very first formula, and that is cosine of A plus B. So cosine of A plus B is equal to cosine of A multiply with cosine of B minus, so if you're adding inside of that cosine, it's actually going to be the difference. It would also be cosine of A, cosine of B, minus sine of A, sine of B. So here is my A, and here is my B. So I'm going to follow the formula, and so it's going to be cosine of A, and my A is 30 degree, multiply with cosine of B, and my B is 45 degree, minus sine of A, and according to this example, A is 30, and sine of B, and that's 45. Okay, so that's it. That's how you apply that formula. And now all we have to do next is just evaluate. And I like to just evaluate trig by just remembering what cosine means and what sine means. So cosine is the x value on that 30, 60, 90 degree right triangle. So remember our special right triangle. Okay, so that's 60 degree, 90, here's 30 degree, that's a 1. And I always remember that it's half of an equilateral, so next to the 60 is the 1/2. And that means the leftover side must be that root 3 over 2. Cosine is going to give me that x value, which is really the adjacent. You can use SOHCAHTOA if you want. So it's adjacent to 30. Well, that's root 3 over 2. Cosine of 45, this one's the easiest. It's the 45, 45. So we know that the two sides are the same. It's root 2 over 2. Sine of 30, this one is when it's opposite of 30. So here's 30, opposite is 1/2. sine of 45. And that's root 2 over 2. Okay. All right. So we have actually 3 operations. We have subtraction, multiplication by order of operation. I'm going to multiply first before I can even subtract. And with multiplication of fractions, it's top, bottom with bottom. So 2 times 2, that's a 4. Root 3 times root 2 is actually going to be a root 6. They combine together, and you can actually multiply that 3 and 2 under 1 square root. Minus 2 times 2 is a 4. 1 times root 2 is just root 2. And now I get to subtract the 2 fractions. And when you add or subtract fractions, you can only combine fractions when the denominator is the same. And it is. So that means I get to subtract the top, root 6 minus root 2. But I do not subtract the bottom, right? I just keep the bottom, and that is going to be a 4. And that is the answer. So if you evaluate this by your calculator, or you take your calculator and you evaluate cosine of 75 degrees, making sure that the angle unit is in degree, then you should get the same value as the evaluation of this radical expression. Okay, so that's how you apply that first formula. So now, not only do we know how to evaluate 30, 60, 45 degree, we now also know how to evaluate cosine of 75. Okay, so let's try something else. As long as you can break down the angle as the sum or difference of 2 very nice angles, we get to evaluate by hand. Okay, and there's actually quite a bit more application of these formulas later on as you take more math classes, but for now we're just going to learn how to use them. Okay, all right, let's try a sine. So how about we do sine of 15 degree? Well, 15 if you're trying to think of the 15 being the sum of 2 very nice angles, you can do it, but it's not as easy as viewing it as the difference of 2 very nice angles. So 15, if I want to view it as the difference of 2 very nice angles, well, 15 is the difference of 45 and 30. So it is the same thing as 45 degree minus 30 degree, and that will give you 15. So now I get to use the difference formula of sine. So if I take sine of A minus B, it's going to be equal to sine of A multiplied with cosine of B minus cosine of A sine of B. Okay. Now notice when you look at this formula, it's A minus B. So wherever B is, it's not going to include that subtraction. So for this example, if I want to identify my A, it is just A. And then minus, we're supposed to subtract the B. So the B itself would not include negative. It's just going to be the positive 30. So B would be the positive 30. That's B. A would be the positive 45. And then the subtraction is the difference between A and B. So it would be the difference between A and this being B. Okay? So that's very important. You don't want to include negative as part of B. Is equal to. So I'm going to follow along A and B. So this is going to be sine of A, and that's my 45. Cosine of B, and that's my 30. Cosine of A, and that is my 45. Sine of B, and that is my 30 degree. And that is it. now I get to evaluate. Sine of 45, that's easy. That's root 2 over 2. Okay, cosine of 30, well, we just did it up here, so we're going to cheat. That's a root 3 over 2 minus cosine of 45. That is a root 2 over 2. And sine of 30, that's up here as well. And that is 1/2. Okay. Same thing. This is multiplication, subtraction, multiply. So we're going to multiply first. Multiplication of fractions is top with top, bottom with bottom. So that'll be a root 6 on top. And it will be a 4 in the bottom. Subtract. We're going to multiply these two. And that'll be a root 2 on top. And a 4 in the bottom. And what do you know? It's the same thing as cosine of 75. So cosine of 75 is the same thing as sine 15 degree. And you'll see why in a bit. We're going to tie these two together through another trig identity. So this is going to be root 6 minus root 2 over 4. Okay, so why would cosine of 75 be the same thing as sine of 15? Well, remember that sine and cosine are cofunctions of each other. And with cofunction, if I take sine of 75 degree, it is the same thing as its cofunction, but you take the 90 degree minus that 75. And so applying the cofunction, we also get that they must be the same. Sine of 75 must be the same as cosine of 90 minus 75. Well, that's exactly 15. So it makes sense. It makes sense why these two must be the same. Okay. All right. I'm going to do an example using tangent. It's not as often used as the sine and cosine, but I'll show you how to use it. It's a little bit trickier to evaluate with tangent because anytime you evaluate tangent, you also have to evaluate the sine and cosine of that angle as well, because that's really what tangent is, sine over cosine. So let's try that very first equation. So let's try, what is tangent of 165 degree? So remember, we can use this formula if I can somehow break down 165 as either the sum of two nice angles that I can evaluate or the difference of two nice angles that I can evaluate. So I'll let you guys look at this for a little bit and try to think for yourself if you can come up with two nice angles, either as the sum or the difference. And you can either do the sum or difference. So I can come up with both. Let's try this being the difference. Why? Well, this angle seems like a pretty big value. So if I write as a difference, I can use two smaller angles. Well, actually, it doesn't really matter. I'll come up with two examples. So 165. Anytime you see a 5 at the end, usually 45 should probably work out. So let's do that. So 45, well, that means the leftover would be 120. Look at that. They're both nice angles. This being a multiple of 60, this being just 45. Okay, so let's try this out. So this is going to be this formula with A being 120 and B is equal to 45. So this is going to be tangent of 120 degree plus tangent of 45 degree over 1 minus tangent of A, which is 120 degree, right? That's my A, plus my B, which is tangent of 45. Okay, and so for each one, I do have to figure out what is tangent of 120. What is tangent of 120? Well, tangent of 120 is sine of 120 over cosine of 120. What is sine of 120? Well, 120 is in the second quadrant, somewhere over here. And if you're at 120 degree, that is 60 degree less than 180. So when I draw my reference triangle, that angle right there, it's probably too small, but that angle down here is a 60. Okay, so let's remember our special right triangle. Next to the 60 is going to be the 1/2. And that means this guy is root 3 over 2. So in my unit circle, I can fit that special right triangle in. So what is sine of 120? What is the y value? The y value is the root 3 over 2. Cosine of 120, so what is my x value? The length of this triangle is 1/2, but x value, the coordinate, the point on the unit circle, because you're in the second quadrant, my x would be a negative 1/2. And so if you divide by a fraction, that is the same thing as multiplying by negative 1/2. Without this parenthesis, it will look like I'm subtracting. So I'm going to put a parenthesis to clearly state that we're multiplying the two. So if you multiply, what do you get? A positive with a negative is a negative. You multiply top with top, that's root 3. Oops, sorry. Forgot to flip the fraction. If you divide by a fraction, you multiply by the reciprocal. So this is negative of 2 over 1. Okay, so let's do this again. So top with top, 2 root 3. Bottom with bottom, that's a 1. So 2 times 1 is a 2. And then you get to cancel out that 2. It's going to be a negative root 3. Okay, so that goes right there. Plus, and that is going to be a tangent 45. This one's pretty easy because tangent 45 is sine of 45 over cosine of 45. And 45 degree, sine and cosine, they're equal. So sine of 45 is the same thing as cosine of 45. So if you take something divided by the same thing, it's a 1. And this is tangent of 120, which is negative root 3. And you multiply by tangent of 45, which is a 1. And so the top is negative root 3 plus 1, and the bottom is 1 minus, so it's actually a plus root 3. All right, that actually looks pretty bad, but if you rationalize this, it could potentially be something a lot nicer. So how do I get rid of the bottom radical? Well, you multiply it by something called the conjugate of this guy. And that conjugate just means that if it's addition of two values, the conjugate will be the difference of these two values. Okay? So I'm going to multiply this by its conjugate, which is going to be the difference of 1 and root 3. But if you multiply that bottom by 1 minus root 3, we have to multiply the top by 1 minus root 3 as well. Okay. All right. So why would this work? Well, if you multiply the sum with its difference, the inside and outside term would actually cancel each other out. So we've learned this in the first half of pre-cal. So I'm just going to complete the multiplication. It's going to be 1 because it's the square of the first. And you'll see that the outside and inside term will cancel. And you multiply last with last, it'll be minus. And what's root 3 times root 3? 3. So the bottom is just 1 minus 3. The top, you do have to FOIL. So first with first will give you negative root 3. Outside, it's going to give you a positive, right? Because it's negative times negative. But what's root 3 times root 3? It's a 3. 1 times 1 is a 1. And last is going to be 1 times negative root 3. So it's a negative root 3. Okay, let's clean up the bottom. It's a negative 2. And 3 plus 1 is a 4. I'm going to write that 4 in the very front. And you have a negative root 3 minus root 3. So you're taking away root 3, but you're taking away another root 3. And that's the same thing as taking away 2 of those root 3. So minus 2 root 3. And you're dividing by negative 2. If you just do that, that is very wrong. But it looks very tempting. You cannot cancel out that negative 2 because negative 2, it's not really a negative 2, right? It's a subtraction 4 minus the 2 times the root 3. The only way to really cancel out the 2 is to somehow make it a factor on both top and bottom. So here's how we're going to do it. That negative 2 is the same thing as negative 2 times 1. Yeah, very, very trivial, but that's going to help us see how negative 2 is a common factor on both top and bottom. If I want to cancel out this negative 2, I'm going to have to factor out a negative 2. So if I factor out negative 2, is it just a 2 for that very first term? Well, if it is just a 2, I would not be able to get back that 4. Negative 2 times 2 is a negative 4. So actually, to get back that 4, the remaining factor inside would have to be a negative 2. Okay, so negative 2 would be the remaining factor once you factor out the negative 2 from this 4. And for this second guy, if I factor out a negative 2, it will just be a positive root 3. So now negative 2 is a factor in the bottom. Negative 2 is a factor on top. Cancel that because it's a common factor both top and bottom. And if you divide by 1, it is the same value back. So it's just going to be this negative 2 plus root 3, which is a lot nicer than this value, which is also the answer. But here, this is a fraction that involves a radical both on top and bottom, whereas this is a radical, but there's no fraction. So this is a lot nicer once you rationalize the answer. Okay, so this is just a few examples of how you would apply these formulas. You guys should try the rest of the homework out. If you have any questions, please post it on Canvas, and I will post up a solution for you guys The next video will be on section 7.3. Thank you guys.